Witam wszystkich bardzo serdecznie. Nazywam się Błażej i reprezentuję firmę Alstor SDS. Dziękuję za przybycie na nasze dzisiejsze webinarium zatytułowane Data Center w erze Edge Computingu. Dzisiejsze webinarium zostanie poprowadzone przez Williama z firmy Scale Computing. Oddaję głos Williamowi. William, you can start.
Thank you for your kind words, I hope. Hi, my name is William van Collenburg. I am a sales engineer at Scale and I cover the EMEA region. On this slide, where you see my name, you also see the email address and the phone number of my colleague Thorsten. He is from Germany and he is the sales manager for your region. If after this webinar you have any questions, please feel free to reach out to Blaž, and obviously also to Thorsten for any questions, any inquiries. Please let us know. So a small introduction into Scale Computing. Scale Computing is a company in hyperconverged infrastructure. We have our headquarters in Indianapolis in the United States, and we have an R&D environment in San Francisco in California, and we have our EMEA head office in the Netherlands, and multiple offices around the globe, currently in Germany, UK, Canada, and France for Europe. We have over 3,000 customers and over 10, actually this should already be 12,000 systems installed around the globe, and we are very proud of having a net promoter score of 91. Especially in the area of support, our customers are very satisfied with what we do. We have a number of technology partners, people that we work really close with, people that we have joint programs with. Amongst those are Lenovo. Lenovo is our hardware supplier. So a Scale appliance will always be delivered on a Lenovo server. We have an alliance with Google Cloud Platform. We have the possibility to create a hybrid environment with them. We have a relationship with APC for their data center racks, but also for their UPSs, and later on we will see a use case where we worked together with Lenovo, APC, Intel, and Microsoft to get a very large project done. We have a couple of OEM partners, amongst which are NEC, Acronis, Leostream, Parallels. These are technologies that we can include in their stack, or they can include us in their stack. Scale was founded originally in 2008, purely as a development company. And while developing in 2010, we decided to adopt KVM as a hypervisor for what we then dubbed a hyperconverged infrastructure. In 2012, we launched into the market with this product, and obviously the first question that a lot of people asked us is, have you ever heard of VMware? Because that's supposed to be the biggest and best virtualization engine in the world. And obviously we had heard of it, but for us the problem with VMware was the ever-recurring license cost, the ever-recurring trainings, and etc., and we didn't want to go that. Luckily for us, in 2013, the company with the most servers worldwide came out with the fact that they were going to use KVM as their hypervisor, as their main hypervisor. And till this date, I still don't know a company with more servers than Google does. 2 years later, and to be perfectly honest, at that time I wasn't too happy with it because I was working at VMware, but in 2015, Apple decided to drop VMware in favor of KVM, and saving about 30 million in license renewals every year. So in 2015, we had over 1,500 customers, and we were the #1 KVM based HCI vendor. In 2017, we decided to team up with Lenovo for multiple reasons. We started out using super micro machines, which function fine, but we had some problems with getting parts replaced. Support wasn't what we expected and what we wanted to grant our customers. After that, we went to Dell, but obviously the Dell relationship with EMC and VMware didn't help. So in 2017, when we were looking for a new partner for a very large reference case, we stumbled upon Lenovo and since have a very close working together. Also in 2017, or actually in 2016 we were called, but in 2017 we released. We were called by Microsoft, by Google, because obviously Microsoft with their Azure offering have a hybrid solution which is called Azure Stack. You can have local AWS, and Google didn't have the opportunity to offer a hybrid scenario. So they contacted us, and together we developed the HC3 Cloud Unity. I'll get into details a little bit more later, but basically it allows you to create a hybrid environment between local resources and cloud resources. And we are very unique in this, in the fact that we can actually offer a VXLAN, so a layer 2 coupling to the Google Cloud environment. In 2018, we launched hyperconverged Edge for edge computing, again, together with Lenovo. And in 2019, Scale and Lenovo, we've launched the on-demand hyperconverged 3 solution. So you could actually go to the Lenovo configurator and configure a Scale solution. Couple of customers that we have around the world, just to show you that we are well presented in not just the US with Kyocera, Airbus, Hilton, and Paris Community Hospital, but also in Europe with, in the UK, Soho Hospitals, with Holiday Inn in France, with the National Bank, with Coca-Cola, but mainly one of our biggest here is Ahold Delhaize. Ahold Delhaize is a supermarket chain like Spar in Belgium, and they had a desire to renew the shop infrastructure. Their existing IT infrastructure was very resource intensive to manage, and to give you an example, they had a lot of single solution servers in a shop. So they had a server there which usually was just a desktop computer as the cash register or the point of sale server. They had a separate computer managing the air conditioning, a separate computer managing the cooling systems for the refrigerators. They had one for a couple of things. So they had 6 or 7 roles that they had to use within that shop. Because these were all single solutions, they had a requirement for very, very, very high SLAs. So they had, with all their contractors, they had 2-hour SLAs. So within 2 hours, somebody needed to be in a shop to get things fixed. Because obviously, if your point of sale system doesn't work in a shop, you can basically, just close your shop. So they needed to have a lot of different things, and preferably in an HA fashion. So we got into contact with Delhaize, and we introduced them into our system, explained them what it was all about, and well, it is currently a reference case, so we got the job done. So right now they have simple next business day SLAs, and they have a fully HA cluster with replication into the main data center. So what we are selling is hyperconvergence, and for those of you who don't know yet, although I am assuming that everybody here is kind of aware of hyperconvergence. Hyperconvergence is the combination of your compute power, your storage power, and the hypervisor into a single solution. So where do we position ourselves? In terms of pricing, you see the typical street pricing of or actually a graphical representation of typical street pricing. You see that in terms of pricing, we are quite equal to a traditional VMware environment. Although I have not taken into consideration with this traditional VMware environment that you actually need a separate storage environment to get that to work properly. If we take a look a little bit higher, you see that once you go for VMware vSAN, so the hyperconverged version of VMware or Nutanix with Acropolis, you can see that we are in a better place. And well, let's not talk about the cost of Cisco HyperFlex. Why is it so difficult? Why is IT infrastructure being kept difficult? Well, it's very easy to write complex software. It's very easy to create software where I have to make the user of that software still think about what he's doing. It's very difficult to make easy software. I'm kind of assuming that a couple of you people are currently looking at their iPhone and saying, well, I've got something over here that is really simple. Keep in mind that Apple has been developing for many years to get something to work that simple. I'm not saying that we are, but our aim is to become the iPhone of infrastructure. So to have a system that is so easy to work with that someone with 2 or 3, let's say half a year of IT experience is able to work with it. Another thing in terms of complexity, right now, VMware offers you 118 different training courses to operate a VMware environment. And obviously, you don't need all of them. Usually 2 or 3 are sufficient, but that's 2 or 3 trainings that, at least where I live, they cost about 3,000 euros for a week, and then an additional 300 euros for an exam. For our solution, we have 1 training, which is not mandatory. And the only reason that we have it is because in the United States, we wanted to get our FedRAMP certification. And to get FedRAMP certification, you need to offer a training. So that's why we have that training. I know that every single storage vendor in the world has once identified itself with a Formula One team. We are actually not identifying ourselves with a Formula One team, but I do have a nice analogy with Formula One. So if you take a look at a Formula One team, you have many, many different teams that work within a Formula One team. For example, the Mercedes Formula One team is almost 300 people large. And in there, they have a separate department for engine tuning, a separate department for tire management, a pit stop strategy. And what you require in this environment is that those different teams have outstanding cooperation. They work in isolated knowledge centers, and this is a very capital-intensive operation because it takes a lot of money to even just pay those people's salaries. You can compare this to a complex IT environment. In an IT environment, I have my networking team, I have my application management team, I have my virtualization storage team, I have my security officers, etc., etc. All these teams require outstanding cooperation. They work in isolated knowledge centers, and also in this case, it's a very capital-intensive operation. Many of us want to drive a Formula One car, but many of our customers are simply not capable of doing it. I am a large fan of the sport myself. I have this nice racing simulation, but I am pretty sure that if I tried to get into one of these cars, this picture would be me. I would have been crashed in, probably in the second corner, if not in the first. What we want is to drive off in the morning like you normally would. You get into the car, you either turn a key, push a button, you put it into drive, or you put it into first gear, and you can drive away. There's just a couple of things that you need to do, and then you can go. This is also how easy infrastructure should be. Of course, we all want to be the fastest, the quickest, the whatevers, but we also need to make sure that we keep an eye on what do we really need. So HC3 is built onto 3 technologies: virtualization, servers, and storage, and 4 pillars. First pillar being simplicity. Well, I've already talked about this, but for us, it's extremely important that you have a single piece of management, pre-configured storage, quick deployment, and basically everybody should be able to work with it. Availability is a key factor in basically modern IT. You can't have a solution anymore that does not have high availability. However, our system also features self-healing. It features built-in backup and replication, and offers you the possibility for disaster recovery as a service. Scalability. Companies start small, and every small company that starts eventually hopes to be one of those big multi-billion-dollar companies. Luckily for us, we don't all make it. But you need scalability. You need seamless scale out, and you need to be able to grow in a fashion that you like. You do not want to grow amongst a determined path, but if your mission changes, the way that you grow should be able to change too. And it needs to be affordable. It needs to be affordable, and it needs to be reasonable. So a common architecture of modern virtualization, as you can see here, usually consists out of a couple of x86 servers with a SAN attached, with a hypervisor installed on it. And over here, I have a lot of layers of complexity. I need to manage the hardware. I need to manage the storage. I need to manage the software on the storage controllers and stuff. I need to manage the virtualization layer. And each and every single one of these layers allows me to fill rigorously at it. What we've built, the hyperconverged solution that we've built, is 3 physical, or at minimum at start, 3 physical machines with internal disks, with internal networking, with internal virtualization. It's just a single solution. And our software manages all of these different aspects. To give you an example, an update within our system also includes all firmwares and stuff like that. So what sets us apart from our competition? So you've already seen the slide with all the pricing, or with the pricing example where we approximately are. But what makes us different from all those other products, excluding vSAN here, because vSAN operates in quite a different way. Mostly all of our competitors work like you see in the left part of the screen. All of them have what we call a virtual storage appliance infrastructure. So for instance, with a Cisco HyperFlex, it's actually called a virtual storage appliance. With Nutanix, it's called the CVM, and every vendor has its own name for it. But in general, this is a virtual machine. This VSA is a virtual machine that claims the disks in a system, that attaches to the hypervisor, and in such a way makes sure that VMs can communicate with the storage in the system. So in this left example, I have this virtual machine over here in the middle. Let me turn on my laser pointer. I have this virtual machine over here in the middle that wants to change a point into a comma in a virtual machine. So what needs to happen? It's actually this one. What needs to happen here is that this virtual machine needs to go to the hypervisor. It needs to go from the hypervisor. Actually, this line is not entirely correct. From the hypervisor to the virtual storage appliance, from the virtual storage appliance back to the storage, from the storage back to the hypervisor, or actually back to the virtual storage appliance and back to the hypervisor, then to the network card, to another node, and do that same thing again to get that data redundantly stored. So in short, that is approximately 36 steps that you need to get a point changed into a comma. Each and every one of those steps goes through a processor or through a process, depending on what your technology is built on. And every time that you go through a processor, you introduce latency. In our solution, in the way that we handle it, is we have not created a virtual storage appliance, but we have created a hypervisor driver. This means that a VM that tells its hypervisor that it wants to store something immediately gets direct access to the storage driver, and through the storage driver to the disks. So to change a point into a comma in this solution, it only requires 12 steps. Now, bad mathematics tells you that that's approximately 66% more efficient. The efficiency in here is not the only thing. The virtual storage appliances are originally intended to take older technology and basically glue them together to create a hyperconverged infrastructure. To do that, they have to run a lot of workloads. And these virtual storage appliances are typically very high resources machines. So as for an example, in Nutanix, the minimum size for a virtual storage appliance is 24 gigs in a 3-node cluster. This means that if I have a 3-node cluster, I have 3 VSAs, I need 72 gigs of RAM only to turn on the Nutanix solution. I do not have any virtual machines running yet. Worst case, you go to HP Simplicity. With HP Simplicity, the minimum RAM size for a virtual storage appliance is 64 gigs of RAM. So if you have the minimum configuration, you require 192 gigs of RAM just to turn on the solution. You don't have any VMs running yet. In our example, we reserve 4 gigs of RAM for each node, period. So to turn on the solution, I need 12 gigs of RAM. And in terms of core, we use a fraction of a core per node. So in a 3-node cluster, you would say that you use approximately 1 core in total. So that makes it a lot more efficient. The one thing that I still left out is the 4 gig and a fraction of a core that I'm talking about in our cluster. Obviously also includes the hypervisor because we cannot separate it. In the virtual storage appliance model, that 72 gigs of RAM is excluding the requirements of your hypervisor. So there is an additional cost there. I've written this out, but I'm not going to bore you with this. You will be sent a copy of this presentation so you can take a closer look at that. So the HC3 advantages, again, simple, available, scalable, affordable. It fits any size of deployment. So we can deliver our machines with as little as 16 gigs of RAM and 4 cores in a system, all the way up to the larger Platinum 28 core CPUs ×2 with 1.5 terabytes of memory. We have very intelligent storage pooling. I'm going to show you that in a demo. There's no need to configure anything in storage. No VSA architecture, no third-party licensing. So you buy this solution and this solution is complete. And there's another thing to add here. There is no such thing as a part license. So with other technologies, if you want to do just virtualization, you can do with a minimal license. If you want to do snapshotting and cloning, you have to have a medium license. If you want to do replication, you have to have the Enterprise Plus with a golden edge and a nice sticker license. We don't do that. We have one product which does all these features. No expertise required and flexible in building clusters with different nodes. So on that note, I have over here our deployment samples where I have an example of a very large cluster in the middle. As you can see, this cluster is built up out of different nodes. We have the ability to do mix and match in these in this configuration with a single node as a remote office branch office solution replicating into the main cluster, a 3-node cluster replicating into the main cluster, and maybe a system with larger disk to function as just a backup unit. Obviously, with the opportunity to, these large clusters to make 2 of them, so do disaster recovery for larger environments. And we have the micro data center and nano data center in a box offerings. More on the last one, the nano data center will be in the April timeframe. And we have the possibility to do the Google Cloud Unity, and we're looking at AWS and Azure in the near future. So what is this made up of? We have the smallest models are the HE100, or actually it's the HE150, but it's the 100 series. We have the HE500, which is the pizza box server, the 1U server, and the tower server over here. And obviously the HE100 is the Intel NUCs that you see over here. We have the HE1000, which is, for people who know the Lenovo lines, it's the SR630. It's also a 1U server, but this one will fit up to 1.5 terabytes of RAM and 2 Platinum processors. We have the HC5000, which fits more disks. So basically it's the same as the HC1000, but it fits more disks. And we have Cloud Unity. So the thank you here is from my colleague Thorsten Schäfer from Germany. Again, you will get a copy of this slide. So if you need additional information, please feel free to reach out to Blaž and to Thorsten. And let's see if I can show you how all of this works. There we go. Any questions, by the way, in the meantime? Obviously, you can also ask your questions in Polish, and then Blaž will translate for me. Okay. No questions there. Do you have any questions, Blaž?
Well, I believe that maybe people will have a question after the whole presentation. So if appear the question, please write to my email. Maybe I will tell this in Polish. Jeśli pytania pojawią się w trakcie oczywiście prezentacji, to mogą je Państwo zadawać na czacie. Jeśli po całym wydarzeniu będą mieli Państwo jakieś pytania, to zapraszam do kontaktu mailowego. Jeśli nie będziemy my w stanie udzielić odpowiedzi, to na pewno poprosimy Williama albo Thorstena ze Scale Computingu o pomoc w udzieleniu prawidłowych informacji dla Państwa. Okay.
Thank you for that. Cool. So what we're looking at right here is a Scale cluster. This one is running on a beta firmware, but there's nothing in here that does not exist in any other firmware, so we can use this one. So on top you see our beautiful new logo. I don't know if any of you have checked our website before, but last week we updated our house style with a beautiful new logo. This one is called the Scale SSD cluster. Keep in mind that this is only a name. This is not a type or anything. This is just my colleague who called this the SSD cluster. And you see the version number over here. When there's an update available, there will be a yellow line of text below here saying there's an update available. And when I click on that, I will go to the update page. Well, obviously there's nothing in there right now, but when there's an update available, you will see text over here with what's in the update, what will be the new features, etc., etc., and a big black button that says update now. Like I said, the system is very intelligent by itself, and it does most of the things completely by itself. So also an upgrade is a completely automated procedure. The update will start with first evacuating the first node, then checking the first node for any hardware issues, then upgrading it. Keep in mind that that upgrade is not just our software, but it's also the firmwares within the machines are being upgraded in that same update. Once the update is done, the machine will be checked again, and if it's found to be healthy, then the workloads will be placed back. Then we go to the second, etc., etc. We go to the third, and all of this is obviously without any downtime. Now, a rolling upgrade might not be a very unique thing. There's lots of technologies that do rolling upgrades, but I think what is unique and what is a really nice extra within our solution is that also the rollback, if something fails or if something breaks during the upgrade, the rollback to a known good state is also completely automated. Going to the middle of the page, you see the telemetry of this cluster. So how much resources is the entire cluster consuming? So you see here that currently there's 28% of CPU being used, 45% of RAM, almost 60% of disk. There's not a lot of people working on this, but keep in mind that this cluster is in the United States, so most of the activities will be during their daytime. And I have approximately 1.43 milliseconds in latency, which for a scale cluster is relatively high. We usually operate somewhere between 300 and 800 microsecond latency. But this is the complete latency for the entire cluster. So it might be that there's a couple of workloads actually doing something. With disk, we can click on the disk overview, and this tells us that we currently have 6.3 terabytes of space available. About 25% is being used for snapshots, and about 31% is being used for virtual machines. In efficiency, you can see that we are currently saving 2.9 terabytes of data through deduplication. In other words, there's a deduplication engine working continuously. And this cluster, well, it is a demo cluster. It has been handed out approximately 10 times in total. It's over provisioned 10 times by making use of thin provisioning. Then one level down, you see these 3 large blocks. These represent the physical nodes in our cluster. You see that each of them has their own IP address. I'm currently accessing this through a URL, but I could access this management GUI that you see over here through all 3 of these IP addresses. There is no single master node. There is no management server. There's no vCenter kind of like thing. Management is done and can be done from each of the nodes. So even when one of the nodes fail, you can still do all of your management without any problems. The white lines that you see over here are a representation of memory. And you see that this VM actually, its name is shown. That is just to identify that this is, in terms of memory, relative to the rest of the cluster, quite a large virtual machine. But the only reason that we show this is to show you how much memory is being used per physical node. Same with the disk overview. The disk overview is intended to show you how much disk space is being used. And obviously, when you're running out of disk space, this middle sector of the telemetry will also turn orange, saying you need to think about maybe adding a node or maybe adding functionality or adding storage. Last but not least, if you take a close look, I don't know how small everything is for you, but you might be able to see that this system actually has 3 spinning disks in there and 1 SSD. So this is a hybrid system. And in a hybrid system, we have something that's called heat, which is our auto-tiering system. So the system will decide what data is being stored on SSD or what data is being stored on spinning disks. Although I will show you later on that you have some tuning capabilities. All the way on the right over here, my notification center. You can see I have 6 notices. I have only, for each node, only 2 of the 4 network cards connected. So it gives you a message that not everything is connected over here. Going one step lower, these blocks that you see over here, these are the virtual machines that we have. Again, this is a demo cluster, so it's not very organized. It's a little bit messy. But the gray virtual machines are turned off. The white virtual machines are the ones that are turned off. Now, going to my own demo VM. This is the default view of a virtual machine. So the name, the tags that are given to the virtual machine, and its telemetry. Now, when I create a new virtual machine, I obviously give it a nice name. I can give it a description. Let's do something. Now, these tags are really important to this system. As you can see, my virtual machine is organized in a folder that says Demo William. So the first tag that I give this machine will be its so-called grouping tag. If you take a look at this, it will say group. Now, if I give it another tag, you will see that this is gray. So all of these tags can be used by the search field and the filter field. So it's a good thing to think about, how do I want to organize this? For instance, if I have high maintenance machines and low maintenance machines, I would give a tag that says high, so that when I want to do something, I can just type over here high maintenance, and I will get all those VMs that are in there. If there are certain VMs that you need to back up and certain VMs that you don't need to back up, you could use the backup tag to configure things later on to have something to do with backup. Below this, we can select the operating system, so either Windows or something good, and we can choose what type of drivers we are going to use. If I choose the performance drivers, I will be using the Red Hat virt.io drivers. When I choose compatible for the virtual disks, I will then use an IDE driver, and for the network cards, I will be using a Intel E1000 connection. Obviously, you should always go for performance unless there's a really specific reason that you don't want to. Then I can choose the number of CPUs, and this is obviously bound by the amount of CPUs that I have in a single node. So I have 6 core nodes with hyperthreading, so in total I can hand out a maximum of 12 cores per virtual machine. If you have larger CPUs, you can obviously give out more virtual cores per virtual machine. I can choose the amount of memory. I can add a drive in gigabytes. I can add another drive in terabytes, and I can select a boot image. Obviously, we have a cloning engine built in, so you would want to create a template VM maybe once, or maybe a couple of templates VMs, and then afterwards create clones from that machine. Because obviously I still would need to install this, but when I create a clone is immediate. So in this virtual machine space, under the power button, I actually have a graceful reboot and a graceful shutdown, and I have the power off option, so to just virtually pull out the power plug. The console, for the console, we have the same rules as we have for the management GUI. This console can be launched from any node in the cluster, and you don't require any additional software to run this. As you can see in this browser session, there's no additional plugins being loaded for this console. Then over here, the telemetry, we've already seen this. The only thing that I want to tell here is that if you take a really close look, you can actually see that there's a difference between sending and receiving information. Over here, I have my devices. And you can see that when I create a new device, if I create a Windows device, it will create 2 DVD drives. If I create a Linux or other machine, it will create 1 DVD drive. And the only reason for that is that Linux does not need additional virt.io drivers. It's already built in. And with a Microsoft operating system, I actually need to load the drivers for the virt.io system. Another good reason to create templates. Then below here, you see the disks. And what I've tried to achieve here is give you a small overview of what a traditional database server would look like. So back in the days when we would still work with physical SANs, you needed to really think about what you wanted to do with your disk space for databases. So usually the C drive, if you had boot from SAN, would be a RAID 1 for a good balance between capacity and performance. You would have usually a RAID 10 or something like that for your tables, for your log files, because you need to have the fastest storage performance you can get out there. And you would have a RAID 5 or maybe even a RAID 6, the slowest one, for your bulk storage, for the table spaces where all the retired data is going to. In the HC3 environment, we have a way of tuning what a virtual disk can do. And keep in mind, this is a per disk setting, so I can have different settings for different disks in a single system. It's over here at the bottom. You can see the heat priority, and the heat priority is a way of setting a priority on data on that disk. If I set this all the way to 0, to off, all data for this virtual machine will be written to spinning disk. Once I set it to 1 or higher, all data will be written to the SSDs, but the lower the priority, the sooner that data will be offloaded to the spinning disk. Our best practice is to basically leave everything at normal, and the system will find its own way in getting a good balance for all of your VMs between getting data in the right spot and performance. The higher you put this preference, the longer it will take for that data to leave the SSD. And when I set it all the way to 11, this will make sure that, or it will make sure, this will try to keep all the data on SSD. Well, you heard me say try, because obviously your SSD space is not unlimited, but it will try as long as possible to keep that data on SSD. The other configuration you can find over here is a live expansion. So I could actually create a larger disk here, enlarge this disk so you can work with it. What I've done in this environment, so I set the C to normal. I set the F and the H drive to 11, being high performance, and I set the G and the I drive to 0, being the low performance disks. Underneath over here, you see the network card, which is a VirtIO. Network cards cannot be configured when the system is powered up, so I'll take the one over here, where I can choose what kind of device I want to use. I can change the MAC address. If, for instance, for licensing, you need to spoof a MAC address, you can do that over here. And I can actually place this one in a VLAN. Now, what you can see over here is when I do not configure a VLAN, it says VLAN all over here. This means that if you do not configure VLANs in this system, the network card will be created promiscuous and will be able to speak to all of the VLANs when you start doing VLAN tagging in your driver. So you'd have the ability to do other things. At the bottom over here, we have our snapshot engine, and somebody who's looking very quickly could see that I currently have 81 snapshots over here. And this is for me the right time to tell a little bit about our file system. So most of our competitors, because they're using this virtual storage appliance, have done a couple of things to get that storage to work with the VMs. The first thing is they need to claim all the disks in a system. So the hypervisor owns these virtual disks or these physical disks, and through the hypervisor, these disks are presented to the virtual storage appliance. Then that virtual storage appliance needs to put a file system on top of that to make sure that it can operate that. Then it needs to put a distributed file system on that to make sure that they can use all the disks in the entire system. And then usually they put an object-based file system on top of that to make sure that they can do their own smart storage stuff like snapshots and the likes of that. What we have done, and the reason that we can do with a driver instead of with a virtual storage appliance, is we have created a block-based distributed file system. So we can immediately address all the different blocks on all the different disks in all the different nodes through a single driver, meaning that we can be a lot more efficient. Because our snapshots are allocate on write like our competitors, but block-based instead of object-based, we don't need to copy around data. So imagine an object that is 2 megabytes and you change, let's say, 2 or 3 K in that object, then obviously the 2 or 3 K will be written to a new place because it's allocate on write. But then the other part of that 2 megabytes object still needs to be copied, and that causes a lot of performance issues. We don't have the requirement for those copy mechanism, so we can be a lot more efficient, and we actually support up to 5,000 snapshots per virtual machine in this system. Compare this to the 20, maybe 25 on a VMware system, and not older than 2 months. 2 weeks, because otherwise it will go haywire. I have here, this virtual machine uses the My Uber Important Stuff schedule, which I'm going to show you over here, where I do a snapshot every minute, which I keep for 6 minutes, to overlap with every 5 minutes, which I keep for 65 minutes, every hour that I keep for 25 hours, every day that I keep for a week, every week which I keep for 6 weeks, and every month which I keep for a year. And there's no one blocking me from saying, well, give me one test, give me one that is monthly every 12 months, so basically every year, and keep it for 380 weeks, which is approximately 7 years, which is, at least in Netherlands, it's the retention law. You need to save all your data for 7 years for inspection by the tax officers, etc. So I could literally do this and create a VM with even more snapshots. Yes, that's quite fine. Thank you. So what I'm going to do right now, just to make sure that I can easily find it, I'm going to make a manual snapshot over here, and I'm going to show you a file level recovery. So over here you see my demo server, and my demo server has a lot of important data. Wichtig is German for important, belangrijk is Dutch for important. There's a lot of important data over here, and my manager asked me, said to me, you can't have this on your desktop, you need to have this in a nice folder, because that's good practice. So I told him, yes, absolutely, you are right. Unfortunately, I was drinking a lot of pivo yesterday, and I selected the wrong folder. Then my colleague came in, he saw the trash bin was full, and he emptied the recycle bin. Normally spoken, right now, I would have lost my job, but luckily for me, I have a snapshot engine, so I can place that data back. There is a small problem with that, because my new friend Blaž is also working on very important data, and I have to secretly check his name because my Polish isn't that good. And in the meantime, he has also created important data. Now, when I copy or when I revert back to a snapshot, obviously I have all that older important data back, but I would lose everything that Blaž created right now, because a snapshot is a point in time. And at the point in time of my snapshot, this data didn't exist. So we created a really, really nice integration into our snapshot engine, saying we can actually manage the snapshots of all these disks separately. So what I can do right now is I have this C drive. I know it's on my C drive because, you know, it's on my desktop. I have this C drive over here, and I can actually select a VM, can be another VM, a recovery VM or something like that, where I can mount that snapshot to get that data back. I am lazy, so I'm going to do it on the same VM, but normally you wouldn't want to mess around in the disk manager of a VM. So I'm going to do it over here. So I'm going to click this button, mount this device, and what you will see is a clone of this device is being made, and it's already completed and being mounted to my virtual machine. Now, when I go over here, I can go to my environment. You see that, you should see that, yeah, I get an additional 2 drives. So it's the system reserved from the C drive and the local disk. I can go to this local disk. I can go to users. I can go to administrator. I can go to my desktop, and I can copy all that really important data back over here, and I get to keep my job. In the end, I go back over here to my devices, remove the reference to that J and K drive. And this is another good reason to never do this on a production machine, because you don't want to be deleting drives over here. I go back to my virtual machine over here, and you can see that the drives that I just had are gone right now. Should be gone. Oh yeah, they're gone. Anyway, our snapshot engine also allows you to do file-based recovery. Now, I know, and you guys know, that a snapshot is never a good backup, because if you lose the original, the snapshot is worthless. Same goes for a replica. We also have a replication engine in here. You don't need to buy any additional licenses. It's just in here. Unfortunately, I can't show it to you right now, but it's in there. But in a replica, if I delete a file in the original, I automatically also delete it in the replica. What we do is snapshot-based replication. So both of the originals and both of the snapshots are present on both sides. So if something happens to the original, I can use the original on the other side. If something happens to a file and I lose everything on one side, I can go into a snapshot on the other side. And that makes it so that we actually dare to say that our replication-based, or our snapshot-based replication is a backup mechanism. Now, obviously, this is file-based only. There is a quiescing engine in there, so I do have application-consistent data, but we cannot restore a single database line, or we cannot restore a single email or something like that. You would still need an additional backup product for that. However, for simple VM replication, for simple VM restoration, and for a simple file backup at a customer, you could definitely use just our solution to work. So for the other part, for where you do need a full-fledged backup system, we have a very nice integration with the Acronis people, the people from Acronis, where you can buy a single license per physical node and back up unlimited virtual machines. And that kind of concludes my presentation. Any questions?
Probably there is no questions at this time. Well, we received from you Polish flyers, Polish materials. So if the people want to know something more in Polish, probably we will send to all participants the new flyers. And if appears a question, of course, William, we will share the question with you and Torsten. And yeah, so maybe I will say goodbye to everybody in Polish.
Before you do,
yeah?
Thank you so much for giving me this stage, and thank you all for attending.
Yeah. Okay. Dziękuję Państwu bardzo za uczestnictwo w naszym dzisiejszym webinarze. Mam nadzieję, że spełniło Państwa oczekiwania. Jeśli pojawią się jakieś pytania po zakończeniu dzisiejszego webinaru, zapraszam do kontaktu mailowego. Tak jak wspominałem, otrzymaliśmy od Scale Computing już przetłumaczone ulotki na język polski dotyczące właśnie rozwiązań Scale Computing, więc jeśli Państwo będą zainteresowani, oczywiście po webinarze roześlemy je do Państwa. W każdym razie webinar jest nagrywany, więc w przyszłym tygodniu najprawdopodobniej również do Państwa wrócimy z linkiem bezpośrednim już do nagrania wideo, więc będzie można sobie łatwo wrócić lub też podzielić się z innymi Państwa współpracownikami. Z naszej strony to wszystko. Jeśli nie ma pytań na czacie, to dziękuję Państwu bardzo za uczestnictwo. William, there is no question at this moment, so thank you very much for your time, and I hope the question will appear after the webinar.
Thank you so much, and have a great day.
Thanks. You too.
Cheers.